All right. These are actual equations that have different bases that we're going to have to solve. Here, there's no way to make 4 turn into a 5 without using logarithms. So, since the calculator only has log and natural log, we're going to use one of those two. We could technically be fancy and try to use one of the two bases we see, but then you just have to use the change of base formula. If you just start with log base 10 or natural log, you don't have to make that worry. All right, so let me take our equation. 5 to the x plus 2. This is equal to 4 to the x. And what we're doing is we're going to apply a log to both sides, just like we can square root both sides or apply an exponential to both sides. But it must be to the entire side. So log of 5 to the x plus 2. The x plus 2 comes down because it's an exponent. We bring powers down. So it'll be x plus 2 like that in parentheses times the log of 5. Log of 5 is something we could type on the calculator, so it's some ugly decimal. And you could just type it in and write the decimal down and then work the problem like that. The mathematician in me, though, like the more I come up with the decimal, the more I'm rounding, so I tend to not do it as much as possible. So I have x plus 2 times log of 5 equals x times log of 4, because we powered down the x. All right. This looks weird, but we can do this. So over here, this log of 5, if it was just a 5, I'd distribute it through. It's the same if it's log of 5. So I have x times the log of 5 plus 2 times the log of 5 equals x times the log of 4. All right, so 2 of those terms have an x, because remember, terms are just multiplication of things. And the 2 times log 5 has no x. So I'm going to minus this guy to the other side. I'm going to write it a little off center on the right because while they both have an x, the logs are not the same base and the same number inside. So we're not going to be able to directly easily interact those. So 2 times the log of 5 equals, so x times log 4 minus x times log 5. Both of those have an x. So I'm going to pull out that x and then write log 4 minus log 5. All right, so that is set up for the quotient rule. We could technically write it as the log of 4/5. Meh. Like x is nearly by itself. Our last step is just going to be to get x by itself by dividing by the crap. The crap in this case being the very ridiculous log 4 minus log 5. All right, so when you type this, most calculators, when you type log, will open a parenthesis for you. So it can be helpful when you're looking at your work to write those parentheses in so you see when you need to close them. So up top, 2 times log, if it opens 1, I type the 5 and then I have to close it. Now notice in purple, I put parentheses around the entire denominator because it has a minus sign in there and I need to keep it all together for the division to work correctly. Each log is going to open its own set though, so we're going to have a lot of parentheses here. So it can be helpful to keep track of them like this. All right, now we're actually going to crunch that bad boy. So 2 times regular log of 5, close parentheses, divided by open parentheses, log of 4, close, minus log of 5, close and close. So we have x is negative 14.42513, blah, blah, blah. Now, our original equation was an exponential. So 5 to the negative 14 plus 2 is going to be the same as 4 to the negative 14. So let's see. 5 to the, that weird answer, plus 2, close, gives me something in scientific notation because it's negative, so it's an ugly fraction. And then 4 to the weird recent answer equals, and I look, and both of my weird answers are the same. So let me see if I can, yeah. See, they're both with the E negative 9 scientific notation. That's times 10 to the negative 9th. So these are very tiny decimals, but they are the same tiny decimal. So that's a way to check where you're not necessarily writing the check step, but you are performing it. All right. Same song, second verse. So I've got my 2 to the x and 3 to the x plus 1. Let's go ahead and use a natural log this time, just so you can see the way I write both of them. There are times where we will choose natural log because the problem has an E. Some people just choose natural log because they like it. Whatever. So we're going to bring the x down, power down. So this is x times the natural log of 2. And then over here, this is the whole exponent x plus 1 times, now this is just a number, natural log of 3. So I need to clear my parentheses by distributing. So this stays xln 2. This is x times the natural log of 3 plus 1 times the natural log of 3 is just the natural log of 3. But if you want to write the 1 times for that first line, just so you remember you did it, that's fine. Now you might ask, why don't I write natural log of 3x? Because if you write it that way, it looks like the 3 and x are both in the log. And what we're saying here is that it's the natural log of 3 as a number times x. So if you want to write the x after it, put parentheses around the before the ln and after the 3. To be very clear, do natural log of 3, then multiply it by x. So that's why I just keep writing it in front. So to me, it's very clear. This thing is a number. This thing is not inside the log. All right, now I'm going to minus the x times natural log 3. So x times natural log 2 minus, I put the x up front, times natural log 3 equals the natural log of 3. And divide by the crap next to x. Now I know, gut instinct is like, ooh, I see the natural log of 3 twice. I should cancel. Don't do it. No, no, no. There's subtraction on the bottom. You ain't gonna do any cancellation unless it's only multiplication division. Now, if it was the natural log of 3 times the natural log of 2 on the bottom, then yes, we could cancel the natural log 3's. But realistically, you're gonna use a calculator to calculate this anyway. may as well let the calculator worry about reducing if it can or whatever. Don't try to save your calculator work. Let your calculator do the heavy lifting. Your job is to know what to type and why that's what you're typing. All right. Now, let me go back and put those parentheses just so you see them all. All right. Natural log of 3, close, divided by open. Natural log 2, close, minus natural log 3, close, close, equals negative 2.7095, blah, blah, blah. All right. Rewind to the original. So 2 to the negative 2.7 equals 3 to the negative 1.7. Sure. All right. These next two here have e's. They only have the e on one side, so it does make them a little bit different. We don't have double exponentials, we now have single exponentials. And this is the kind of problem that you will see in a chemistry class that you have to solve, especially if you're looking at half-life problems. Most of the time, the chemistry book writes it in terms of e rather than in terms of 2. Sometimes they do the 2, though. It doesn't necessarily make sense. But all right, so I have 100 equals 20 times e to the 2t. So I need to solve this for t. So there's a times 2 I need to deal with, there's an e I need to deal with, and then the 20 on the outside. So the 20 is the outermost, 20 times. So we're going to divide both sides by 20. So this is now 5 equals e to the 2t. Now to cancel out e to the, we need to use log base e, which is natural log. So I am going to choose to apply a natural log to both sides, the whole side. So the left natural log of 5 is something I can crunch on the calculator, so it's a number. On the right here, the log of something to a power down. So this will be 2t times the natural log of e. Now I know some of you are like, but Liz, doesn't it cancel? It does. I'm just going through it so you see it cancel. So the natural log of e is asking e to what power is e? Better be 1. All right, so if this is 1, 2t times 1 is just 2t. And now we would divide by 2. And yeah, I'll go ahead and divide by 2. But caveat, make sure you close that parenthesis after the 5 before you put the divide by 2. Because the natural log of 5 halves is not the same as the natural log of 5 divided by 2. All right, so let's see what we get. The natural log of 5 close and then cut in half is 0.80471, blah, blah, blah. All right, so this was some sort of growth thing, and it happens, this thing will grow to size 100 from size 20 in 0.8 time periods. I don't know enough about the problem to be able to say if that's days, months, years, hours. Don't know. And then number 6 here, same thing. So we're going to start it out by dividing by 3. Now we're stuck with a fraction. Meh. So this is e to the 0.5t equals, I'm going to leave a little space, 11/3. To cancel out e to the, I'm going to natural log. What I do to one side, I do to the other. And then here, the power comes down, natural log of e is 1, so we'd have just our power. 0.5 t equals the natural log of 11/3. Then last step, we're going to divide by 0.5. So now we just got to crunch that on the calculator here. So natural log 11 divided by 3, then close the parentheses, then divided by 0.5, which is actually the same as multiplying by 2, so that's why the number got bigger. 2.59856, blah, 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 blah. All right. So there we go. That is our solution for that one. All right, next video is going to be logarithmic equations finally. So stay tuned for that.